Hello all and welcome to the algebra video for an equation review. Okay, so equations review. What we're going to do here is just work a bunch of different equations that we have covered in the past. So I did want to point out that these are all equations, types of equations we have covered before. Okay, and I did want to point out as well, if you look at the assignment online, if you are a virtual student, do practice all the equations on your own. Technically, there are some instructions there telling you to go and have other people work some equations. This is ideally for group work in a class setting, not a online virtual setting. So, and in terms of that, you can kind of ignore the instructions about getting other people to work the equations. It would be beneficial, though, if you did work all of the equations. And that's what I do suggest you try before watching this video is go through, practice all the different types of equations. So it's broken up into topics. So you've got topic one, which are multi-step equations, which has to do with, of course, multi-step equations, equations with variables on both sides, um, also equations with infinite solutions and no solutions. Okay, so all that's included in this first topic. Okay, because all of them pretty much work the same in that you've got to distribute, you've got to combine like terms, you've got to do all the steps that you would in a normal equation. All these are what we would consider, I guess, normal equations, meaning, like I said, distribute, combine like terms, and then simplify. Okay. Then you go into topic two, which is just a couple questions there on proportions. Everybody seems to have a good handle on proportions, so it's just a couple questions there, but still practice with them. Okay, so if you need to go back and look, which we're gonna, go over these here in just a moment, anyways. But you have proportions. Topic three, absolute value equations. Okay, so make sure you know how to do absolute value equations. So there's 4 examples of that. And then lastly, we do have topic 4, which are what they call in the sheet multivariable equations, but what we called literal equations. So these are literal equations where you're solving for a specific letter. Okay, you're solving for a specific variable, and there are more than one variable. Okay, so with that being said, I do suggest, like I said, pause the video, practice all these on your own. Okay, and then I'll come back to the video here, and we'll go over them together. Okay, so if you have worked those out, let's go ahead and jump into it. So topic 1 here, multivariable equations, or multi-step equations. I apologize. These are just going to work out like any of the equations we've done before, in that you see the parentheses. That means you need to distribute something. Okay, you got some like terms you need to combine. Are there variables on both sides? Okay, how is all this going to work? Well, it works the same way every time. So in this case, we see the parentheses. So first thing here, we need to distribute the 6. So this first part becomes 6x plus 18, because once again, we're taking the 6 and multiplying it times the x and the 3, minus, well, what's going to be here? Well, once again, you can think of this as a minus 1. Well, what are we distributing a minus 1 to? The x and the 4. So many of you probably found out the shortcut here is if you got a negative 1 here, it changes this positive x to a minus x. So minus x, and then this plus 4 to a minus 4. And that's where I see a lot of people still maybe struggling, is they forget that if you got a negative on the outside of parentheses, and you'll see this again in another equation here in just a minute, but that this means you need to distribute a negative 1, which means it changes the signs here, meaning that x becomes a minus x, and this plus 4 becomes a minus 4. But now when we get to this point, once again, technically it's a negative 1 minus 1x. We got some like terms, so we can combine the 6x minus 1x. That gives us 5x. Okay, and that's taking care of those. And then we have 18 minus 4, which is a positive 14. Okay, and then now from here, just like all the rest of these equations pretty much, is when you get to a certain point, you have a 2-step equation. 5x is equal to negative 25. Divide by 5, so we get x in this case is negative 5. Now these are a little bit tougher, but you can check your answers with these. So plug negative 5 back in. Negative 5 plus 3 is negative 2. 6 times negative 2 is negative 12. Negative 5 plus 4 is negative 1. Okay, so you got negative 12 minus negative 1, negative 12 plus negative or plus 1, which is negative 11. Okay. Number 2 works almost exactly the same way, except for you notice in this case there are variables on both sides of the equation. And just like I've said in class before, and just like I've said in videos, if you need to, draw you a line down through here so you can keep track of what side's what on the equation. So if you have trouble keeping track of what I'm adding or what I'm subtracting from one side to the other, draw that line so that way you can keep it straight. Okay. But the thing here is we see parentheses, so that means we need to take this negative 8 and distribute. So we have negative 8n, and then this minus 4 is going to become a plus 32. And if you need to, technically you could put a 1 in front of this n. So you got a choice here. You can either subtract 1 n from each side, or you can add 8 n to each side. And it's actually up to you. But as I've done before, I like to stay consistent with it. I like to move my variable from the right-hand side to the left, meaning I subtract 1 n here. That means I've got to subtract 1 n from the negative 8n, so that gives me negative 9n plus 32 is equal to negative 40. And then now we're at the same point here where we have a two-step equation where we will subtract 32. So we get negative 9n is equal to negative 72. Divide by negative 9, divide by negative 9. N is equal to negative over negative is a positive. 72 divided by 9 is 8. Okay. So once again, kind of going back here a little bit, but all these steps that you knew how to do from before. So distribute, combine like terms, get rid of a variable term on either side. Okay. All those are still relevant here because once again, this is just a review. These are all equations types of equations you've done before. Now, when you look at number 3, same kind of thing. See the parentheses. Okay. Let's distribute. 7 times the y is 7y. Minus 7 times the 5 is 35. We still have the plus 3y. And then over here, 10 times y is 10y. Plus 10 times 1 is 10. Well, over here, we can combine like terms. So we got 7y plus 3y. Once again, what's in front of the term is what you do to it, meaning what's in front of the 3y? Well, plus, that means you would add the 3y. Okay, so that would be 10y minus 35 is equal to 10y plus 10. And some of you might be already seeing something's going on here, but we got an option. We can either subtract 10y from each side, or we could subtract 10y from each side. So it's actually the same no matter which way you do it. But if we subtract 10y from either side, we got to do it to the other side. Like I said, what I mean by sides is draw a line down through the middle, the equal sign. Because what's going to happen here is those are going to go away. Those are going to go away. So we're left with negative 35 is equal to 10. And based on what we've done before, we know when we get nonsense like that, negative 35 is not equal to 10. Okay, so let me do this because I want to really show you. Negative 35 is not equal to 10. So what that means is this actually means there are no solutions. But I want to point out that the steps to solve this are the same as the steps we used to solve number 2. The same as the steps we used to solve number 1, except for number 1 we didn't have a variable on the left or on the right-hand side. Okay. Now number 4, same kind of thing. We see the parentheses, so we distribute. Negative 5 times k minus and a plus, so that's going to make this minus 10. 13, and then technically you can think of there's a negative 1 here, so it's negative 1k plus 1. Okay, that's where a lot of people get a little mixed up here is, once again, this negative on the outside of the parentheses, technically you can think of as a -1. And if you do -1 times -1, it's a +1. The same kind of thing here. We can't really do anything to the left side yet, so I'm just going to rewrite that down again. But I can do some things over here. So the only variable term I have is this -1k. But then I can combine the constant terms because I have 13 plus 1. That's a positive 14. And now we have an equation pretty much like what we had in number 2, where we have a choice. We can either add 5k to both sides, or we can subtract, or we can add 1k to both sides. Okay? Like I said, I like to be consistent, so I always like to get rid of my variable term on the right over here, meaning those will go away. So -5k plus 1k is -4k minus 10 is equal to 14. And then, just as always, you get to this two-step equation place, okay, where you would add 10, add 10. -4k is equal to 24. So that tells me that we divide by -4, and k equals -6. Okay. So like I said, same exact steps. Just you got to make sure you do them in order, though. So like, don't subtract 1 from anything before you distribute, because once again, that k minus 1 is in parentheses. Don't add 2 to the -5 for whatever reason, because once again, the plus 2 is in parentheses, so that tells us we need to distribute. Okay. But once again, the same steps we used to do number 4 are the same steps we used to do number 2. The same steps we used to do number 1. Technically, the same steps we used to do number 3. Okay, except for, once again, in the process of doing that, we got something that didn't really make sense here. Okay. Number 5, same kind of thing here. We see the parentheses. We have another instance where we have this -1. Okay. So -1 times what's in the parentheses. So this -6 stays out here. We're going to have -2x because it's a positive 2x, -1. So it means -2x. And this +7 is going to become -7 because, once again, this -1, that's what we're distributing. Okay. That's equal to -2x. Okay. In this case, +6 is going to become -12 minus 1. And then we got some issues here where we can clean up a little bit of this on the left-hand side. So I'm going to rewrite this as -2x. That's the only variable term. Well, then we've got -6 minus 7, which is a -13. Okay. So once again, that's the constant term minus a constant term gives me a negative constant term. So -13, -2x, -12 minus 1 is also -13. And then once again, some of you might be able to look from here and say, oh, this looks like something we've done before. Well, it is, because once again, we got a choice. We can either add 2x or add 2x. So I'm going to pick to add 2x to both sides. And what ends up happening here is these will go away. So we get -13 is equal to -13. That is always true, meaning there are infinite solutions. But in this case, we really got to pay attention to our distributing here. We really got to pay attention to what terms we're adding together and everything. So once again, always look at front of the terms. So the negative has to go with the 2x. So if we move it out front, what ends up being left behind is the -6 and a -7. So -6 minus 7, or -6 plus -7, gives me the -13. Number 6, same kind of thing here. Distribute. Distribute the 4. That gives me 8x plus 28. We have a 12, but then I distribute technically a -2 here, which gives me -20, and then plus 4x. Okay. Once again, changes the sign in here since it's a negative 2 and a negative 2x or minus 2x. It's going to become a plus 4x. So can't do anything to the left-hand side. That's still just 8x plus 28. But over here, we see that our variable term's 4x. Let's go ahead and write 4x. But what's left over? 12 minus 20 is a negative 8. So we're at the same point we were right here. We've got a choice. We can either subtract 8x from both sides or subtract 4x from both sides. I'm staying consistent. I'm going to subtract 4x. I'm going to subtract whatever's over here. Subtract the 4x. 8x minus 4x is 4x. Plus 28 is equal to negative 8. And then we would subtract 28. 4x is equal to negative 36. Divide by 4. Divide by 4. X is equal to negative 9. Okay, so I don't know how much more I could say in terms of all these pretty much work the same in that all of these you had to distribute. All of these you had to combine some sort of like terms. All of these you've had to, besides number 1, all of these you've had to subtract a variable term or add a variable term to each side, okay? So once again, just practice with these. Try them out on the homework, but go through and make sure you know how to do these 6 questions because that's the thing, especially if you're in Algebra 1 Part 1. Next year, you're going to have to take an SOL test. They're going to throw equations at you like this where you don't know if it's going to have infinite solutions or no solutions, okay? You don't know if it's going to have an answer or not, meaning what the answer should be. So that's the thing. You really got to have the steps down because it's not as easy as just knowing that what the answer is just by looking at the equation. Because once again, we're in some very difficult types of equations here that you really got to pay attention to what you're doing. And like I said, the best way to do that is practice. Okay. So that's why we're doing this review here. But then we go on to topic 2. And this is one I think most people have an easier time with, but it kind of makes no sense to me because whenever you solve a proportion, as you'll see, you'll actually end up with an equation kind of like what we just had in numbers 1 through 6. So what I mean by that is number 7. As with all proportions, how we start them off are we do cross multiplication. So we do the little butterfly here, meaning we take the 5 times x minus 9, 7 times x minus 3. So again, if you remember watching my videos, technically I'm doing this for a reason. I'm going to do the 7 times x minus 3 first. Then I'm going to do the 5 times x minus 9. Now, where people did mess up with these is they forgot to include the parentheses, okay? Technically, with each one of these, you can think there's parentheses around it. So you've got 7 times x minus 3 in parentheses. 5 times x minus 9 in parentheses, because it's important you have the parentheses because technically what you need to do next is distribute. And now we're at the same point. So what we've done here, once again, all I've done is distribute each one of these numbers, 7 and 5. Now we're kind of like what we had. We have what we had with all of these questions where we have variables on both sides. So at this point, so we're at this point, meaning we can either subtract 7x from both sides or subtract 5x from both sides. And like I said, if you have a preference and you want to subtract the 7x here, you can try it out and see that you should get the same answer that I do here, okay? But I'm just going to be consistent. I'm going to subtract the 5x, meaning 7x minus 5x is 2x minus 21 is equal to negative 45. And then, once again, 2-step equation time where we add 21, 2x is equal to, in this case, negative 45 plus 21 would still be a negative, but it would be a negative 24. And then the last step, of course, is to divide by 2. So we get x is negative 12. Okay. So once again, a lot of work there, okay, in terms of having to do all these steps. But at the same time, after you get past the proportions, after you get past the cross multiplication, it works just pretty much like any other equation we've done before. Same thing with number 8. Technically, we want to cross multiply here. And once again, I'm going to do this in a specific way, and you don't have to do it this way, but I'm doing the 5 times 3x plus 6 first, and then that's going to be equal to 6 times the thing x minus 10, times the expression x minus 10. So now, same kind of thing. Once we get done with this, same step, we distribute. So we get 5 times 3x is 15x, plus 5 times 6 is 30. 6 times x is 6x, minus 6 times 10 is 60. And then once again, we got a couple different things we could do. We could either subtract 15x from both sides or subtract 6x. So I'm going to subtract 6x. Okay. Once again, the whole point is we want those to go away. So we have just negative 60 over here. 15x minus 6x is 9x plus 30. Subtract 30, subtract 30. 9x is equal to negative 90. Divide by 9, divide by 9. X is equal to negative 10. And just like with any equation that we've done, I did it with number 1, but I haven't done it since, but you can do this on your own. Like you don't have to, and for me, you don't have to write it down. But if you really want to make sure you get your equation right, plug this back in. Negative 10 minus 10, that's negative 20. Negative 10 times 30, okay, so that's going to be negative 30 plus 6 is negative 24. Negative 20 over negative 24, well, that reduces down to 5, 6. So that is true. That's equal, okay. Then we get to absolute value equation. So we're getting closer to the end here because this is something that should be a little bit more recent. Now, number 9, we start off with a super easy one. The absolute value of x is equal to 9. Well, that means the absolute value of x is equal to 9. That means x can either be 9 or x can be negative 9. Because once again, if you plug either one of these back into the original expression, the absolute value of 9 is 9. The absolute value of negative 9 is also 9. Okay, but we can't forget, so if we have two answers for an equation, okay, and you'll see this a little later, is we have a solution set. Okay, meaning both of these numbers are in a set because they are both solutions to the equation we just solved. Okay, but then we go to number 10, but it's the same kind of thing in that, all right, we've made it a little more difficult here because instead of an x, we have a c, but then what's inside the absolute value? Well, 6c minus 3. The thing to notice here is the absolute value is by itself on the left-hand side, so we can go straight into solving two different equations. We can do 6c minus 3 is equal to 21, and we can do 6c minus 3 is equal to negative 21. Okay, and now once we solve both of these equations, same steps, add 3, 6c is equal to 24, divide by 6, c is equal to 4, add 3, 6c is equal to, in this case, negative 18, divide by 6, c in this case would be, so let me make sure I mark down all that, negative 3. Okay, so in this case, not like number 9, we don't have just the positive and negative of the number. So that means our solution set's actually going to be 4, negative 3. That's the thing to remember about all of these absolute value equations is if you get an answer, and I'll go ahead and tell you all these absolute value equations that we're going to work on here have answers. You should always get two answers, okay? You either get two answers or no answers. There's no in between, okay? Well, There is a case when you can get one answer, and that's when the answer is 0, because it's not a positive 0 and a negative 0. Okay, so if you got the absolute value of something's equal to 0, or the absolute value of x is equal to 0, well, the only thing that has an absolute value of 0 is 0. So, like I said, you can't have like a positive and a negative 0. But anyways, number 11, same kind of thing, except for you notice you got 7m inside of absolute values, but then the plus 4 is on the outside. So what I've done in class and what I did in previous videos is think of this absolute value as its own thing. So you can say that it's a plus 4 is equal to 25. And now we need to isolate this. We need to get the absolute value of 7m on the side by itself. Okay, meaning once again, if we can change that to just the absolute value a, then all we got to do in C is we just got to subtract 4. So we get a is equal to 21, which what did that mean? That meant 7m. Absolute value 7m is equal to 21. Now we can break it apart and do the two different equations. We can have 7m is equal to negative, or I guess I always do the positive first, so positive 21. And we can have 7m equal to negative 21. And solving these equations are really easy because all you got to do is divide by 7. So m is equal to 3, divide by 7. In this case, we actually do have just the positive and negative of a number, so m is equal to negative 3. So my solution set is 3, negative 3. Okay. And then the last one here of absolute value, number 12. This one's the most difficult one. We use the same thing that we talked about over here with number 11, in that we want, notice over here, it's not just an absolute value that's over here by itself. We've got the absolute value times 5 plus 3. Okay. So like I said, take that absolute value and kind of treat it as its own thing. So 5a plus 3 is equal to 33. Well, that means two-step equation. We just subtract 3, subtract 3. 5a is equal to 30. Divide by 5, divide by 5. We get capital A is equal to 6. Which, what was capital A? Well, that was that whole absolute value we had up here. Absolute value of 2n plus 8 is equal to 6. And then once again, we can do the thing where at this point, since we have the absolute value isolated by itself over here, we can solve 2n plus 8 is equal to 6. And we can solve 2n plus 8 is equal to negative 6. Whereas, once again, just two-step equations. So we get, in this case, n is equal to negative 1. And n is equal to negative 7. But once again, that tells us we've got the solution set negative 1, negative 7. So both of those equations work. And once again, these are equations with solutions. Plug these back in. Okay, negative 1. 2 times negative 1 is negative 2. Negative 2 plus 8 is 6. Absolute value of 6 is 6. 5 times 6 is 30. 30 plus 3 is 33. Plug in negative 7. 2 times negative 7 is negative 14. Negative 14 plus 8 is negative 6. Absolute value of negative 6 is 6. 5 times 6 is 30, plus 3 is 33. Okay. And then we have the last set here, the last topic, which are just two equations. I think there's 4 on the homework, though. But these are what we call literal equations, meaning, all right, you have this equation here. Let's solve it for y. So we have w is equal to 1/2 x squared times y. So since we're solving for y, we treat the w and the x and, of course, the 1/2 as numbers. So if x is a number, that means x squared is a number. So what are we doing to y? Well, we're multiplying it times 1/2, and we're multiplying it times x squared. So first things first, to get rid of this 1/2, we would multiply both sides by 2, or 2 over 1. And that's to get rid of the 1/2. So what's left? X squared y. Well, at the same time, we still want the y. Well, what are we doing to the y? Well, now we're multiplying it times x squared. But we don't really care what x squared is. We don't care what x is. All we care about is that we know since x is a number, x squared would be a number. So we just divide by x squared. So our answer here is 2w divided by x squared is equal to y. And then we go to number 14. In this case, we have c is equal to 8a minus 3b. And it says we need to solve for a, so this is what we need to solve for. Well, what are we doing to a? Well, we would multiply times 8, then subtract 3b. Once again, we don't care what b is. We don't care what c is. That we just know that they're numbers, and we focused on a. A is the variable we want to solve for. So if we're multiplying times 8, then subtracting 3b, then that means in reverse order we need to add 3b. But in this case, c plus 3b, we don't know what that is, so we just have to write it as c plus 3b. Once again, we're still looking at a here. Well, all this over here is just a number. 8's just a number. We're multiplying a times 8, so divide by 8. But that's the thing. We got to divide the whole thing over here by 8. So my final answer here is c plus 3b all over 8 is equal to a. And now the whole point in doing stuff like this is if you know W and you know X, well, now you know Y because you just have to plug it in and do order of operations. Same thing with number 14 here. If you know C and you know B, plug them in, do order of operations, and now you can figure out what A is. Okay, pretty easily. All right, so that pretty much does all the review questions here. So use what we just did right here. There is a homework for this section, so even though it's just review, it is basically a big old review homework as well. So if you look back and look at all the different things that we've done, these all work just the same. Okay, so definitely go back and look at the examples we just did. Make sure that you, once again, ask questions if you run into any trouble. But like I said, this is just a big review on equations, and it's all equations that we've done before. So everything here nothing should be a surprise, okay? But if you do need help with something, just please let me know. And I do say good luck on your homework. And as always, thank you for watching.